Okay guys, so welcome back. We're going to learn today about the inverse trig derivatives. I've had a lot of people have been asking us this question. What is the derivative of those inverse trig functions you guys learned about? So what is the derivative like inverse sine of x, or inverse cosine, or inverse tangent? So I want to remind you guys about what we know, right? We know like all these derivatives. We made this table a while ago, and recently we learned the derivative of sine, a cosine, tangent, all that stuff. And today, our goal is to figure out what is the derivative of inverse sine of x, inverse cosine of x, or inverse tangent of x. Okay, so before we even kind of proceed with that, let's just do a quick refresher on what inverse sine actually is. So I want you to recall that when we say inverse sine of x or arc sine of x, those both mean the same thing. They are the opposite or the inverse of sine of x. So what I want to remind you about that is if we tell you that the sine of pi over 4 is, sine of pi over, sine of pi over 2 equals 1, then if you take the inverse sine of 1, that gives you pi over 2. It's the opposite, right? So if you take the sine of pi over 4, and you get rad 2 over 2. You take the sine of an angle and it gives you a ratio. And what that means is when you take the inverse sine of rad 2 over 2, when you take the inverse sine of a ratio and it gives you an angle. So the inverse sine of root 2 over 2 is saying what angle, so find me the angle theta where the sine of that angle is rad 2 over 2. Well, we know the sine of pi over 4, we just take the easiest one on the unit circle, and that's what we're going to get there. So that's what inverse sine means, and the notation is a little different, but it means the same thing. If we say the arc sine of rad 2 over 2, it's just pi over 4. It's just a different way to write this. One of the reasons people write it that way is just like to remember that if you do like sine minus 1 of x, that's not the same as 1 over sine of x. Like those are two different things, right? Inverse sine is not sine to the negative 1 power. This, of course, is cosecant of x. So anyway, that's kind of unimportant. I just wanted to remind you that. But the important thing today is how do we differentiate y equals inverse sine of x? So let's see if we can find a formula for this. So I'm going to give you a formula at the end, but I want to show you where that formula comes from. It's not super important that you kind of see the math behind, it's not super important that you memorize the math behind this, but I want to show you that this is logical. It comes from somewhere. I don't just make up this random formula. So what I'm going to do on this is actually do implicit differentiation. So I'm going to write this as x equals sine of y. Because that's the means, right? If y is the inverse sine of x, then the sine of y is equal to x, right? That's just the same relationship that we did up here. Okay, so if x equals sine y, now let's go ahead and try implicit differentiation. So when I do implicit differentiation on this, I'll take the derivative of both sides. So I'm going to get 1 equals cosine of y times dy dx. So then furthermore, I will get dy dx equals 1 divided by cosine of y. Now, that's not really that helpful because I'd love to be able to write dy dx in terms of x like the original function. So how can we work with cosine of y? So what do we know about y? So what do we know about y? Well, the best equation we had is right here. We know that the sine of y is equal to x. And thinking about SOHCAHTOA, the sine of y, which is x over 1, we could think about that as an opposite over a hypotenuse. So what I'm going to do is I'm going to draw a picture of that angle y. So in some right triangle, if I have some angle y, if I take the sine of that and get x over 1, that's saying the opposite over the hypotenuse is x over 1. So now what I need to do is using this picture, I'm going to find the cosine of y. Okay, so I'll use this picture to find the cosine of y. Well, I need to find this missing side, right? So let's figure it out. A squared, let's call that a. So a squared plus x squared equals 1 squared. So a is the square root of 1 minus x squared. Okay, cool. So that's 1 minus x squared. So that means that the cosine of that y is equal to adjacent over hypotenuse. So that's root 1 minus x squared divided by 1. Okay. So I drew a picture of this sine of y equation right here being x over 1, and then I found the cosine of that. So once I take that and plug it in, I get that my derivative of inverse sine of x was 1 over root 1 minus x squared. And I got this by using trigonometry to kind of go ahead and show me what the triangle looks like and find the cosine that way. So that's pretty good. That's our derivative of inverse cosine. So let's put that, inverse sine. So the derivative of inverse sine is 1 over rad 1 minus x squared. Okay. Now, most of your homework tonight is just going to be doing problems related to this. Okay, so doing problems related to this, what that will look like is, for example, I will say y is the inverse sine of 3x. What is the derivative equal? Okay. So we're going to apply the chain rule to this. So when you take the derivative, let's see, if I just had a regular inverse sine of x, the derivative would be 1 over rad 1 minus x squared. So thinking about how the chain rule works, well, we have a 3x in parentheses. So we just need to plug in 3x for the x, and then I need to use the chain. So I'm going to plug in a 3x there, so I'm going to get 1 over rad 1 minus parentheses 3x squared. And then by the chain rule, I have to multiply by 3. Okay, so that's the strategy there. Similarly, if we go kind of one step further here and take a look at what if we have y equals the inverse sine of e to the 2x. Okay, so again, it's going to be the same thing. When I take the derivative, I'm going to plug in an e to the 2x. I get 1 over square root 1 minus e to the 2x squared. You could write that as e to the 4x, multiply out, times, again, the chain rule. I have to multiply the whole thing at the end by the derivative of e to the 2x, which of course is just e to the 2x times 2. Okay, so that's how these problems go. You're just going to be going ahead and taking a derivative then of inverse sine and so forth. We're using the chain rule, using the product rule, that kind of thing. I wanted to point out also, if I had written this as arc sine of x, remember that just means the exact same thing. Your derivative is the exact same. Okay, now I'm going to save you guys some shortcuts here. If you want to take the derivative of inverse cosine of x or inverse tangent of x, you could find these derivatives in the exact same way that we just did with the triangle. The derivative of inverse cosine is the exact same as inverse sine's derivative, it's just negative. The derivative of inverse tangent is a little cleaner. It's actually just 1 over 1 plus x squared. That's kind of cool. It doesn't even have a square root, right? The derivative of inverse tangent is 1 over 1 plus x squared. Phenomenal. Okay, so let me go ahead and just show you a couple examples of this. Again, you can come up with these formulas if you want, but make sure you know all three of these derivatives for inverse sine, inverse cosine, inverse tangent. And, maybe fill those out in your table at the top, right? Inverse cosine is the same as inverse sine, but it's negative, and inverse tangent is 1 over 1 plus x squared. Okay, so let's go ahead and do a couple other ones here, maybe just one more example with an inverse tangent. So say I tell you the function is x times arc tangent of x squared. Okay, so we're going to have to do a product rule on this. And again, most of your homework is going to be product rule and chain rule using inverse tan, inverse cos, inverse sine. Okay, so when we take the derivative here, it is first times the derivative of the second. So we're going to plug into this formula. So again, I'm going to plug in the x squared for x, and then I'll do the chain rule. So instead of 1 over 1 plus x squared, it's 1 over 1 plus x squared. And then I'll multiply by the derivative of x squared, which is 2x. And then the derivative of x is 1, and then I still have an arctangent of x squared, or inverse tangent, doesn't matter. So I can clean this up, right? We have an x times a 2x, that's a 2x squared divided by 1 plus x to the fourth, plus the arctangent or the inverse tangent of x squared. Okay. So that's how we're going to do inverse tangent derivatives. Make sure at some point you memorize these three. We're going to see them pop up occasionally throughout the year. And tonight we're just going to be working on the chain rule stuff. All right, I'll see you guys soon. Thanks for watching. Bring me questions.